All right. So, okay, don't forget to say I'm here so I can do your attendance a little bit later. So let's finish a 4.3 and then 4.4 because 4.3 and 4.4 in a way they're same. There's only a little bit differences at like end of 4.4. So now we're gonna learn about definite intervals. All right, definite interval means they will give you upper bound and lower bound. And I only want to calculate the area between upper bound and lower bound, which is upper bound is B, lower bound is A. So where you highlight it right here, this part. So I want to find only area over here and here. These are the only thing I am interested. So this is how you do indefinite interval. Finding area is equal to integral from A to B. Okay, starts at A and ends at B. So this is my lower bound. That's my upper bound. And I'm going to take integration of f of x and dx. So what does that mean? For example, we have this problem right here. This is this graph right here. This graph right here is this 4x minus x squared. So I want to find area of this. Okay, the area looks like oval shape. Okay, so I want to find area of this oval shape from 0 to 4. So area of 0 to 4, and you know how to take antiderivative. Remember, antiderivative means opposite of derivative. So I will add one more power and divide it by the coefficients, right? So this becomes area is equal to 4x 1 plus 1 divided by 1 plus 1 plus x squared 2 plus 1. And I am going to evaluate x equal to 0 and x equal to 4. That's what I'm doing. I'm going to take away plus c because I don't care about plus c anymore, because I am only going to look at those two boundaries. So plus c and minus c, they will cancel out. Do we have exam next week? I will tell you in a minute after we finish with our lessons. So most likely we're not going to have exam next week because I'm still doing a 4.3 and 4.4. I got to do 4.5 next Tuesday. And so most likely I will give you exam a week after instead of next week. All right. But I will probably continue covering other chapters. So we don't stop. All right. So this is how you do. So this means I'm plugging in. First thing, let's just simplify this. So let me see. Let me do that problem. But anyway, don't worry about this one right now. I'm going to finish this one in a minute. I will finish this one in a minute, but I want you to understand the concept. Okay, so let's look at this picture. All right, the area, this is again, I'm finding area. So I'm looking for area 1 to 3, from 1 to 3. Okay, it's a 4. So my function, f of x is a 4. So I'm just drawing a 4 line like that, right? That is f of x equal to 4. But I'm only interested on that boundary, this boundary to that boundary. All right, you know how to find area of a rectangle. So this case, you're gonna say my width is 3 minus 1, which is 2. That's a 2. My length is the same as f of what? F of this, what is this one? F of 3. What doesn't matter, f of 3, f of 2, whatever, they're always 4. So f of 3, which is 4. So this area is 4 times 2, which is 8. We know how to do this kind of problem when the shape is exactly like some stuff, the shape is something that we know how to calculate. We can do geometrically. Okay, geometrically means like a finding area of a rectangle, width times height. Okay, we know how to find the area of trapezoid. Okay, trapezoid is 1/2 times base height times base 1 plus base 2. Yes, we know how to find that. So with this kind of graph, okay, we also know how to find the area. But we can find this area even better, the shape that we don't know how to do, like shapes that is peculiar to us. Yes, we know how to find the area of semicircle. Would it be 1/2 times pi r squared? Because area of a circle is what pi r squared. So half circle would be 1/2 pi times r squared. So we know how to find that. All right, so now we're saying is, okay, how about the shapes like this? All right, shapes like this. This shape is not anything that we know. It's not triangle, it's not trapezoid, it's not rectangle, it has a curve. Okay, look at this curve. I have no idea how to find the area of this. Okay, and then I don't know how to find the area of that because the curve is not known. I don't know how to find it. That's why you need calculus. Okay, integrations. Integration, which is antiderivative, will give you area under that curve, that graph that you have. Like absolute value, the graph looks like this. Right, so I want to find area. They want to know -1 to 1. So I want to find the area of this and area of that. So this case actually is not too hard because it's a triangle shape. So I can find this is the width is 1, height would be what? 1. Width is 1, height is 1. So 1/2. So this area is 1 times 1/2 is a 1/2. This area is 1/2. So together it's 1. Okay. But say we don't know how to do this geometrically. If I want to do this problem using an integral, let's do that, okay? Let me see. Do I have an example? Yeah, right here is example. Say if we have this problem, okay? So let's figure out, excuse me. If they give you problems like this, they gave you, so I'm gonna use a calculus to do my finding areas, okay? So they ask you to evaluate this. In other words, they're asking you, find the area of this particular equation, -x squared plus 4x minus 3. And I want to know between 1 to 3, okay? And they also gave you this. They're saying if only x squared, if it's x squared between 1 to 3, your answer is 26/3. Integral of x between 1 to 3 is 4. They gave you answer, and you gotta use these answers to figure out this. And they also gave you simply, which means 1. 1 dx, integral between 1 to 3, give you 2. So I'm using that information to figure out integral from 1 to 3 of -x squared plus 4x minus 3. So now let's break it in. So this I'm gonna write down as by itself, 4x by itself, -3 by itself. Okay, now you need to make a connection. So this is similar to that one. So we need to look into that. It says x squared, integral of x squared give you 26/3. All right. So if I rewrite this problem and put the negative in the front, Okay, that means this is exactly same as that one. So I just need to simply put 26 over 3 and then put the negative in the front. Okay, are you following me? Next one. This 4x, I can rewrite it. I can rewrite this problem, looks like this. Okay, 4x, I can write it down as 4 in the front, put the x. Okay, this is exactly the same as that one. So that gives me 4. So I have a 4 times 4. Next one. Next one, this and this, we're gonna use that information. -3, I can rewrite it as -3 in the front. And I have exactly the same thing, which is the same as that. So this gives you 2. So 2 times -3, you have that. So when you multiply them out, you get -26 over 3 plus 16 minus 6, they give you 4/3. So area of this is equal to 4/3. Okay, so you have a homework problem that you need to apply this information. Okay, so now let me give you 4.4, because that's the one that I want to go over with you. So this is a fundamental theorem of calculus. The definite integral is a fundamental theorem of calculus, which means over here, this is what they said. This is a very important concept. The fundamental theorem of calculus is if a function f is continuous on the closed interval a and b, so lower limit and upper limit, f is an antiderivative of f, small f, on the interval a comma b, then you can do this. So in other words, if I give you, say, x squared 1 to 2 of dx, all right? What they're saying is take antiderivative of that, which is what? X plus 1 divided by 2 plus 1. I usually plus c, right? But now I'm gonna evaluate x equal to 1 and x equal to 2. By the way, this plus 1 minus 1 cancel out, so I don't need it. Remember, it says what? F of b minus f of a. So that means f of b, this is my f of b. Right, so I'm gonna do x squared, x to the third divided by 3. I'm gonna evaluate x equal to 1 to x equal to 2. That gives me, I'm gonna use 2 different color. So I have 2 to the third divided by 3 minus 1 to the third divided by 3. That's what it's saying. They're saying plug it in the upper bound minus lower bound. Okay, so I'm plugging in this is that, and plug it in that gives me this. So my answer is, my area is 8 over 3 minus 1 over 3, which gives me 7 over 3. So I found my area. So, you know, this graph looks like this. So I am only looking at 1, 2, 3. I'm only looking at this part, this area. Remember, we were using Riemann sum to find area like that before, right? We used to draw small rectangles here, different rectangles to figure out the answers of an area under the curve. Now I'm going to do, okay, I'm not going to do a drawing a rectangle to do using a Riemann sum. Now I'm just going to use calculus. Okay, I'm gonna use calculus, which means I'm taking antiderivative, okay, which means integration of the given problem, and then I will find the area under the curve. Instead of drawing a small rectangles, each one of them, I'm gonna just do it using integrations. Okay, so this is, we learned, okay, we learned physically, geometrically, we learned we can find area under the curve by drawing a rectangle. Okay, now it says if I have a draw many rectangles, like infinitely many rectangles, okay, then I know my answer is like perfectly correct. So now it's saying, okay, then I can take that as like a limit approach to, you know, the end, the number of a rectangle approach to infinity, which equivalent to continuous of kind of like a continuous. There's no discrete anymore, but almost you can think as a continuous. That case is like an integration. Okay, that's integration, it's continuous. You can think as continuous function. Okay, continuous things. So you have this. They gave you example right here. All the things right here. They have this is called fundamental theorem of calculus. For me, okay. So again, I told you we want to use a Julia for a lot of things. So let's just go and practice. So we have these problems. I don't want to do one by one because, okay, actually, let's think about the taking an antiderivative first. So antiderivative of this is what? X to the 2 plus 1 divided by 2 plus 1 minus 3 x to 0 plus 1 over 0 plus 1, because this 3 is the same as x to 0, okay? They're equivalent. So I'm gonna evaluate x to the 1 and x to the 2. I can simplify this. That's the same as x to 3 over 3 minus 3x. And I'm evaluating x to the 1 and x to 2. So that's the same as 2 to the third divided by 3 times 2 divided by, oh, there's nothing to divide by. Okay, that's my upper bound. So let me just look at this as that's my f of b. Now I'm gonna do f of a minus 1 to the third divided by 3 minus 3 times 1. Okay, remember this. You can think of this as your f of a b. That you can think of as your f of a. All right, so you need to finish this one. So whenever I see a lot of calculations, I rather use a Julia. So I don't have to literally calculate by myself. Okay, so let me, I want everybody to open up your Julia right now so you can go with me, do with me step by step. Okay, I'm gonna wait for you to open up your Julia. Go and open up your Julia right now. So you and I would do the same work. So we are doing indefinite, we're doing a definite integral. So today's lesson is what? Definite integral. Integration. And which is, you can think of, we're doing a what also? First fundamental calculus. That's what we're doing. Okay, today's lesson is definite integral, which is first fundamental theorem of calculus. I forgot to put the theorem. First fundamental theorem of calculus. That's what we're doing today. All right, let's look at the example. So example problem that we're gonna do is f of x is equal to x squared minus 3. Excuse me. That's a given problem. F of x squared minus 3. Okay, so let me rewrite it. So that is my, that's my, you can think of a function inside the integral. Okay, that's the function inside the integral. And now I want to find in other words, the function inside the integral is, you can think of, it's a derivative of some function. Okay, derivative of some function. So I'm gonna use uppercase F for X. All right, uppercase of F. That I'm gonna call it as antiderivative of F. Okay, so, or I can call it okay, F of X is so I'm gonna, let me write that. So F of X is antiderivative Are you with me? F of X is antiderivative of F of X. So F of X, tell me, how do you find the antiderivative of F? Capital F is antiderivative of small f of X. So how would you do? Remember, I'm gonna add one more power, right? So X to the, I'm gonna add, originally I had a 2 power, so I gotta add 1 power. All right, are you with me? And I'm gonna do a divided by what? Same thing. And minus 3 times X to what? I used to have a 0 power, now I'm gonna add 1 power. And I'm gonna divide it by same thing. All right, so that's what I just did. Are you following me? Okay. All right, are you following me what I just did? This is my, in other words, I have that's what I have. Okay. All right, so now I need to find antiderivative. I'll call it f of x. Which gives me, that is x 2 plus 1, everything divided by 2 plus 1, minus 3 x 0 plus 1 divided by 0 plus 1. That's what I have. So this part right here is this right here. This is what I did. It's right there. Okay, now I need to solve this one, and where x equal to 2 and x equal to 1, right? So this is what you need to do. So you're gonna do f of 2. It gave you that number. F of 1, it gave you that number. So you can do, so area is equal to what? F of 2 minus f of 1. So they gave you this. So if the area is a negative number, that means your graph is this is what your graph looks like. So 1, 2 is 8. So your graph, you have right here, your area is under the x-axis. So if you have a negative, which means your graph is under the x-axis. Right here. This is your axis. So your area is under. That's why you have a negative. Okay, if you have a positive, such as over here, all right, that means if the area is above x-axis, you get a positive answers. If the area is under the x-axis, you get a negative answers like this. All right, so let's try different boundaries. So if I decide to do same problem, okay, same problem, which is x squared minus 3 dx. But this time I want to do my boundary to be, say, 2 to 5. All right, so which means I'm going to find this is my f of x, which means I want to find, oops. Which means what? I am finding f of x to be x 2 plus 1 divided by 2 plus 1 minus 3 x 0 plus 1 and divided by 0 plus 1. And I am evaluating now, this time between x equal to 2 to x equal to 5. Since I already have that function right here, I don't have to find it again. I just need to do what? F over 5 minus f over 2. So I'm going to say area is equal to that. All right, so let's look at it. I want to make sure that I got the right answer. So let me manually calculate this. Okay, so do you see my screen? Some reason, okay, so I will have, okay, so let's look at that. F of 5, what do I get? That number. F of 2, what do I get? This number. So if I find the area, what? F of 5 minus f of 2, it gives me that. So I am skipping this. So f of 5 minus f of 2, I literally have to do what? 5 to the third divided by 3 minus 3 times 5. That's my f of b. Minus, I have to do 2 to the third minus 3 times 2. I have to calculate this. This I don't have to do by myself anymore because my Julia does for me. And Julia just said that is equal to what? 26.66. And that is my f of b, f of a. Julia said that is equal to negative 3.33. So that's why when you add it together, you get 26.66 minus 3.33, which give you what? 29.99. So that's the area. So by using Julia, you're eliminating a lot of work. The algebra part right here, I mean what's that called? Counting part, addition and subtraction part can be eliminated by using a Julia. So I highly recommend you guys use Julia for your work, because once you find this, your antiderivative, you don't have to do much work. The algebra part, the adding and subtraction part, I mean, the evaluation part, you don't have to do it. Let the Julia does for you. Okay, so let's try another problem. Somehow I cannot erase this. Okay, so don't worry about this part. I'm just going to cross out. Okay, cross out because I'm going to do new problem. So I'm going to try f of x equal to, say, x squared plus 4, x plus 3. All right, so let's try a new one. Can I call it g of x? So I have a different name. Okay, I'm going to call it g of x. So g of x is equal to x squared plus 4 times x plus 3. So that is what? That is a function inside the integral. Okay, integral. So the function inside the integral is that. All right, just like over here. In other words, you can think of x squared plus 4x plus 3 dx. I'm going to call that to be, do you want to use different name instead of a f of x, or you can say g integral. All right, so I'm going to call it g integral of x. All right, so that'll be easy for you. So whenever you see like a g, like f prime, I'm going to call g integral. Okay, g integral means you're taking an integral antiderivative of the function. All right, so what does a g integral is then? It'll be what? X to the 2 plus 1 divided by 2 plus 1 plus 4 times x 1 plus 1 divided by 1 plus 1 and plus 3 times x 0 plus 1 divided by 0 plus 1. That's what you have. So that's what I'm going to write down. So x to the 2 plus 1 and everything divided by 2 plus 1 plus 4 times x to the 1 plus 1, everything divided by 1 plus 1. But if you want just to make sure that it's exactly right, I usually like to put the parentheses around to make sure this is all numerator. Okay, this is all my numerator, and that's denominator. This is my all numerator, and this is my denominator. Plus one more, 3 times x to the 0 plus 1. That's my numerator divided by my denominator, 0 plus 1. So this is what I have. By the way, I like to put, when I put in my Julia, I want to put new parentheses for this. So Julia knows this expression, for that expression is my numerator. That is my numerator. That is my numerator. Okay. So now it's easy for me. So I need to find my area. Area is equal to what? G integral of one number. In this case, how about we do between, say, 7 and 2? I mean, 2 and 7. 2 to 7. All right. So I want to find each one of them first. Let's do that. G integral of a 7. That's that answer. G integral of 2, which gives me that 16 point something. So what's my area? Area is equal to G of G integral 7 minus G integral of 2. So that's my answer, 216. So I just figured out. So my answer is the area, this area over here is equal to 216.67. So let me tell you about your exam. Your exam, when I say show your work, you can use Julia as a screenshot, like what I'm doing right now, as your work. So instead of, for example, instead of doing this one, you're gonna say, I mean, you have to show me, you have to give me what? Right here. Okay, that is my work. So you can do that to be x to the 2 plus 1 over 2 plus 1 minus 3. And then you're gonna do x 0 plus 1, 0 plus 1. Right, you have that. And then you're gonna evaluating between 0 to x to 2 and x to the 5. You're gonna do this work. If you have to show me your work, you have to do this to me. 5 to the third divided by 3 minus 3 and 5 to 1 divided by 1. That's my f of b minus 2 to the 3 divided by 3. 3 times 2. That. And then you have to show me my answer, right? So you don't have to show me this if you do that over here like this. So your work can be showing me a screenshot of Julia. So your exam, again, we have to show your work. So your work can be showing like this, or you can show me like that, which is much easier. Okay, but I put it in your Julia and let Julia do the calculation for you. This calculation over here, you don't have to do by hand because it told you that's equal to 26.66. I don't have to do this part by hand because it tells me that's equal to negative 0.333. So this is equal to 26.66 minus negative 3.33, which gives me 29.999 right here. So you can do your work like this. All right, now I want you guys to do one problem for me. Let me give you a problem and then you do that for me. Let's do a little bit harder. So do this problem for me. Okay, I want everybody to get your calculator, get your Julia out and find me this answer. Okay, so I wanted to call this to be f integral of x. All right, so new problem. So that's the problem that I'm going to do. So f of x is x to the 7 plus 3 times x 2. That's my f. Now tell me, what is f integral of x? All right, somebody help me. Chevion, are you there? Okay, who is actually here? Because I see a lot of people's name, but when I call your name, I don't get any response. Chevion, are you here? All right, Brent, are you here?
I'm here.
All right, Brent, help me out here. What do I do? X to the 1 power. Let's start with the parentheses. X to the, what I do? This is just 7 power, so when I take integral, so what do I do? X, the 7 is there, so x plus one number. 1, always 1 more power. Now when I close my parentheses for my numerator, what's my denominator that I want to put it in? You have this number, the 7 plus 1, you're going to do exactly the same thing over here, 7 plus 1. So I'm done with this first part right here. Okay, Fran, continue this problem. So what do I do? Next part. So 3 times x to what power? What is my power here?
1, I guess.
That's exactly right. So 1 and plus what? What's my formula says? 1 and then what? What did you do here?
Oh, 2.
So you're gonna just add 1 more, right?
Oh,
Those my parentheses for my numerator. What's my denominator? So 1 plus 1. So I do exactly the same thing. What I put it over here, 1 plus 1, I do exactly the same as my denominator. So let's do 1 more. You're gonna finish now, okay? So next one is what? 2 times x 2. I don't have any power there, so it's 0 plus 1. Close my parentheses. I do exactly the same thing. All right, so that is my f integral. So I'm done with my work. Pretty much all the things to be done, I'm done. So f integral of x is x to the 7 plus 1, everything divided by 7 plus 1, plus 3 to the x, 1 plus 1, everything divided by 1 plus 1, plus 2, x, 0 plus 1, everything over 0 plus 1. And I'm going to calculate everything between x equal to 2 to x equal to 5. So in this case, I just need to find then f integral of 5, and number is this. So in other words, 5 to the 8 divided by 8 plus 3, 5 to the 2 divided by 2 plus 2, 5. That is my first one, and minus, and now do 2, so 2 to the 5, 8 minus 3 times 2 to the 3 divided by 2 plus 2 times 2, that's my f of a. So according to my Julia, when you calculate this part, that is equal to that number, 48875,625. Now let's look at the other part. F integral of 2. That gives me this part right here is equal to 42.0. So what is my area then? Area is equal to F integral of 5 minus f integral of 2. That gives me that number. That is my area. So yes, you can show your work like this, which means you're gonna show one by one how you got this number. Or you can just use this way. Okay, that can be your work. So when I say show me your work on your exam, if I were you, I would just use Julia because that will save you so much time. All right, so I want you to try this today and do your homework. And I will finish 4.4. There's 2 parts I didn't finish. There's net change, I didn't finish that, but you still can do your homework. So try to finish 4.1 through 4.4, except the net change part, which I will cover next Tuesday. So cover that and I will cover 4.5. So most likely I'll probably want to give you exam. I don't like to give exam Thursday because I feel like you need to study a little more before you take exam. So I'll probably just go ahead and cover chapter 5 rest of the week. And then I'll give you exam the week after, Tuesday. All right. So have a wonderful weekend. Does anybody have any questions? Does anybody have any questions? Did everybody says I'm here? So I know who's here today. All right, so anybody have any questions over this homework the lesson 4.3 and 4.4 that I just went over? Does everybody know how to use Julia to find your area? Because I want to spare you but tedious work, plug it in numbers and figure out what the f of b equal to, what f of a equal to. Just use Julia, let the Julia does work. You find integrals, okay? You find the antiderivative of the function and then let Julia does the work for you for finding like a f of 5 minus f of 2. That the Julia does for you, because that's the part a lot of people make a mistake anyway, because you're not plugging in your number right in your calculator or something. So I want everybody to do that and do me a favor. Why don't you guys send me a screenshot of the work using a Julia so I can tell you whether you're doing it right or not. So if I give you the pointers now, then when you take your exam, you will not make a mistake and then you get the full credit for it. All right. So if you want me to look into your Julia and see whether you're doing it right, send me a screenshot. I'll let you know whether you're doing it right or not. Okay. I'm just trying to help you out. So when you take your exam, you can get better grade. All right. So exam is not going to be next week, but week after. So I will change your homework date and exam date.